All right, welcome to this explainer. Today, we are going to completely demystify artificial intelligence. And don't worry, we're not going to bog you down with complicated math or endless lines of code. Instead, we're going to explore this through a really beautiful, ancient allegory, the story of the Gurukul of Patterns. I want you to imagine an ancient training ground, a Gurukul, hidden way far away from the noise of our modern world. But here, the students aren't focusing on weapons or reciting ancient scriptures. Their entire focus is on understanding the underlying patterns of reality itself.
So our story kicks off with a young seeker named Arjun. He arrives at this Gurukul and pretty much immediately poses the ultimate mystery to the headmaster, Acharya Caitana. Arjun asks, "Gurudev, how does this system actually know anything?" Think about it. That is literally the foundational question of all artificial intelligence. How do we take a hunk of silicon and wire and somehow teach it to genuinely understand the world?
Okay, let's jump right into Section 1, the way of learning, or escaping the rules.
To answer Arjun's incredible question, the guru draws two very distinct paths in the sand, and this marks a massive shift in how we build systems. Path 1 is the way of rules. The guru explains that in this path, you have to define absolutely everything perfectly. You know, if the enemy is near, attack. Or if the sky is dark, find shelter. This is traditional programming. It's super rigid, and honestly, it's completely limited by the programmer's imagination. But then the guru simply erases those rules and shows him path 2. He says, watch 10,000 battles, observe, adapt, and boom, that is machine learning. The system isn't strictly told what to do, it's just shown the world and learns to adapt totally on its own.
Now the guru points out to the entire training yard and tells Arjun, this right here, this is your data set. Every single warrior out there sparring is a single data point. He explains that the specific traits of each warrior, their strength, their speed, how focused they are, the type of weapon they're holding, those are the features. In AI speak, features are just the measurable characteristics we use to make sense of the data. Arjun's tracking with this, but he wants the bigger picture. So he asks, okay, but what about winning? The guru smiles and replies that whether a warrior ultimately meets victory or defeat in the ring, that final definitive outcome, that's the label. So basically your features are the inputs, the warrior's skills, and the label is the output we are desperately trying to predict. Getting this combo of features and labels right is the absolute bedrock of how any system learns from the world.
Let's move on to Section 2, the cycle of becoming and the birth of a learner.
Meet Manas. He's this quiet student who just perfectly embodies the whole iterative cycle of machine learning. Just look at his daily routine. First, he watches battles, meaning he takes in training data. Second, he practices, which is the training phase. Third, and this is crucial, he inevitably makes mistakes. This represents the loss or error of a model. And finally, he improves his stance for the next round, which we call optimization. Day by day, pattern by pattern, this continuous loop makes him smarter and smarter.
The guru gets a bit poetic here, explaining the variables of this learning process. He tells Arjun that the actual pain Manas feels when he makes a mistake, which, let's be honest, we can all relate to, is the loss function. It literally tells the system exactly how wrong it was. Then, those physical adjustments Manas makes to his stance, those are the parameters, or the weights that shift as the model learns. And lastly, the guru's own instructions right before the fight, like telling him to train longer or dial back the aggression. Well, those are the hyperparameters. They're the preset knobs we tweak before the training even gets going.
But it doesn't always go smoothly, right? Take a look at these two students who completely failed. Student 1 is the memorizer. This guy perfectly recalled every single past battle. But the second a new unfamiliar fight popped up, he totally choked. In AI, we call this overfitting. He memorized the past, but didn't actually learn the general pattern. Then you've got student 2, the ignorant. He barely trained at all and just failed at everything, past and future alike. That's underfitting. So the guru teaches Arjun that true wisdom and a truly effective AI model has to find that perfect balance right in the middle of pure memory and total abstraction.
Moving right along to Section 3, Paths of Knowledge, getting into the deeper ways of learning.
So as the guru points out, there actually isn't just one single way to learn. There are 4 foundational pillars of machine learning. First up is supervised learning. That's when a teacher is right there, handing you the labeled answers. Next is unsupervised learning, where you're just dropped into a crowd to find hidden order and group similar things together entirely on your own. Then we've got reinforcement learning. This one is all about learning through the hard consequences of reward and punishment over time.
And finally, self-supervised learning, which is fascinating. The system actually hides part of the data from itself and learns by continuously testing itself to generate vast amounts of knowledge without any teacher at all.
To really test Manas, the guru starts throwing specific, real-world questions at him. And these map perfectly onto the core problems modern AI solves every day. Asking, is this warrior an ally or an enemy? That's classification. Asking exactly how strong is he on a scale? That's regression. Telling him to group these warriors based on their styles. That's clustering. And finally asking, who is behaving strangely in the camp? That's anomaly detection. Literally every complex AI task you see out there is built on top of these foundational questions.
All right, into section 4, the deep mind, where we look at layers of understanding.
Let's slow things way down for a second. We're transitioning from what AI does to how it actually pulls it off by taking a peek deep inside the mind of Manas. His thought process actually works in these cascading steps. First, the outer layer simply sees the physical movement of his opponent. Then, the next layer processes that movement to figure out the hidden intent behind it. Finally, the deepest layer takes that intent and actively predicts the opponent's next action. Each connection between these thoughts has a certain strength to it, driven by variables we call weights. When signals fire through these layers, highly intelligent decisions just naturally emerge. And that right there is the architecture of a neural network.
But hey, what about language? To show how words are processed, the guru speaks an incomplete sentence. Victory belongs to the... Manas pauses. But here's the catch. He doesn't process this as a string of letters. Language actually gets broken down into these weird fragments of meaning called tokens. And the meaning of a token isn't some rigid dictionary definition. It's actually a specific mathematical position in this vast multidimensional space which we call embeddings.
The guru pushes it further. He gives Manas a tricky sentence. The warrior dropped his weapon because it was broken. And then he asks, what exactly is it? Without missing a beat, Manas mentally points right back to the exact correct phrase, the broken weapon. When a system successfully links a pronoun backward to the correct object amidst a sea of words, it's using something AI researchers call attention. It's this incredibly powerful ability to know exactly what matters right in that specific moment.
And it's this exact ability that unlocks the absolute powerhouse driving today's AI revolution, the transformer. By letting all of these tokens look at all the other tokens simultaneously, the transformer architecture gives the digital mind the power of parallel thinking, a remarkably long memory, and this ridiculously deep contextual understanding that older models just completely failed to grasp.
Which brings us to our final chapter, Section 5, Illusions and Evolution, Exploring the Loop of Thought.
So we've built up to this astonishing reality of how these super advanced models actually talk to us. The guru leans in close and whispers the ultimate secret to Arjun. All of this majestic, awe-inspiring capability basically reduces to a single, relentless loop. What comes next? Add it to memory. Think again. It's literally just next token prediction. Arjun is absolutely floored by this. He asks, wait, all intelligence? Just from predicting the next step? It sounds way too simple to be true, right? Yet this non-stop loop is the core engine running modern generative AI.
But of course, the guru has to give a warning. This prediction engine, it is definitely not flawless. Because it's only predicting what's statistically likely to come next, Manas will sometimes say things that are completely untrue, but with absolute terrifying certainty. In AI, that's what we call a hallucination. And sometimes he makes totally unfair judgments, favoring certain warriors just because his past training data was skewed. That flaw is known as bias. Honestly, these are the exact same massive issues you read about in the headlines every single day regarding modern AI.
To wrap it all up, the guru elegantly summarizes what AI truly is, breaking Manas's almost magical abilities into 6 fundamental acts of intelligence. The system sees the world through perception, hears it through understanding, classifies things through categorization, predicts the future through anticipation, decides what to do through action, and ultimately creates something entirely new through generation.
If we step back and look at the whole timeline of this evolution, the trajectory is wild. In the past, and even right now, Manas grows by mastering very specific, isolated skills, like just battle, or just language, or just strategy. We call that narrow AI. But the future? The future is pointing straight toward the dawn of a system that can adapt to literally anything, anywhere. That massive theoretical leap is what we call artificial general intelligence, or AGI.
As our story wraps up and Arjun is finally packing up to leave the Gurukul, he asks one last question. Is Manas actually truly intelligent? The guru drops this incredibly profound distinction. He says, AI learns patterns of the world. He predicts the next move perfectly. But you you understand why the move exists in the first place. Consciousness questions the patterns. It's such a brilliant reminder of the heavy boundary between really good math and actual sentience.
So Arjun walks away from the Gurukul with his mind blown, realizing that the world itself is our data set. Our actions are just predictions, and our own awareness might just be a constant optimization, which leaves you with this pretty provocative thought to ponder today. If our AI models are out there flawlessly predicting the next thought, and hey, maybe our own brains operate on similar physical patterns, who is actually asking the questions? Thanks so much for joining me on this explainer, and remember, keep questioning the patterns.